All right, let's start. Now, that is I believe my presentation slide is visible on your end. Please confirm.
Not yet, Zablon.
All right. Yeah, I think it was my computer taking so much time to load. No pressure. So, what you're going to learn today at the core of this lesson, you learn how to do the following. Number one, you're going to understand and apply normalization techniques to reduce redundancy and optimize database um, structure efficiency. Number two, we are going to learn the concepts and rules for first, second, and third normal forms to ensure data integrity and minimize anomalies. We're also going to apply database normalization to practical examples demonstrating how to avoid update, insert, and delete anomalies. So let's start with the first topic of the day. So first topic of the day is normalization. Going by the slide definition, normalization is a systematic approach to decompose, break down tables to eliminate data redundancy, what you call repetition, and undesirable characteristics like insertion anomaly in DBMS, update anomalies, and delete anomalies in DBMS. So okay, I know this is the right definition going by books, but there's a definition that I usually use that I find it to be quite easy to remember. So if you are noting somewhere, please write that we can say that normalization is the process of organizing data within a database to eliminate data anomalies. As simple as that. I'll repeat. We can say is the process of organizing data within a database to eliminate data anomalies. It's simple, all right? In simple, it involves breaking down the database into smaller tables. Now, uh, Jared, you want to say something? I don't know if it's you who was unmuted.
Kindly just check the chart, please.
All right, all right. Just give me a minute. All right, cool. All right, well noted. Nice one. Yes, so why is normalization important? So number one, mm, slide there. So why is normalization important? So we have uh, some of the advantages of why normalization is important. We have it reduces redundancy. Don't worry, I'm going to explain and what this means. We're also going to improve query performance. Okay. We're also going to minimize update anomalies and another key advantage is enhance data integrity. If you could allow me to switch from my presentation slide and go to Exalidraw there. So okay. I still have the tables that I was using today morning, but I'll draw new ones. So, all right. So we say number one, reduces redundancy, right? So what does this mean actually? So as I said, redundancy is when the same information is stored multiple times. And a good way of avoiding this is by splitting data into smaller tables, okay? So reducing the amount of data that is being repeated in the tables, okay? That's why we need normalization. Another key advantage is it improves query performance. Like that. So it also improves the query performance. Um, What I mean by this is you can perform faster query execution on smaller tables that have undergone normalization. Okay. Another key advantage of why we need normalization or why normalization is important, it enhances what we call data integrity. So with data integrity, I'm sure almost everyone here has come across that error that says when you're trying to update two different tables, you get that consistent error. Okay, I've been seeing some of you sharing that kind of error in our WhatsApp group and also asking me what kind of error that is. So that means the table that you're using, it was normalized. It's only that you did not know that that table was normalized. So with normalization, it ensures that data remain consistent and accurate, as simple as that, to avoid our data being corrupted. Simple. And then finally, we have what we call minimizes updates anomalies. By this, what it means is just the update errors. So having a normalized table, you find that when you're trying to update your table, you get less errors. So with normalized table, you can easily update data without affecting other records. So this is why we need normalization. But I know you are asking yourself, what causes the need for normalization? So if a table is not properly normalized and has data redundancy, it will not only take up extra data storage space, but also make it difficult to handle and update the database. Okay, so there are several factors that drive the need for normalization. As we've said, number one, from data redundancy to difficulty in managing relationship. So what causes the need for normalization? Let me draw another one here. So we have this. Okay, so these are the importance. Now I'll draw another one for what causes the need. Number one, we can say update anomalies. And then we can also add, okay, so with insertion, deletion, and update anomalies, any form of change in a table can lead to errors or inconsistency in other table if not handled carefully. These changes can either be adding new data to a database, updating the data, or deleting records, which can lead to unintended loss of data. Another key point, we can say difficulty in managing relationship. So last week we covered about relationship difficulty. Or I can just write complex relationship. Like that. So with complex relationship, it becomes more challenging to maintain complex relationship in a normalized tables or structure. Okay, so you cannot manage the relationship between tables when the tables are unnormalized. Okay, another key feature which we learn later is what you call partial and transitive dependency, which we'll cover later in depth. So So partial dependency can lead to data redundancy and update anomalies, and transitive dependency can lead to data anomalies. Okay. Now, let's see the different types of database normalization. We have several. Allow me to go back to the slides. So this is the reason why we need, and then this is the important. So if I can go back. Let's learn the different types of DBMS normal forms. So we have first normal form, we have second normal form. We also have the third normal form, BCNF, which means Boyce code normal form, okay, and fourth normal form and fifth normal form. So main area of focus will be in the first three. So we have this one, and this one. The first, second, and the third. This other one is good to know, but in rare case, you'll be using them. But the one that you'll be using in your day-to-day activities is the first, second, and the third one. So these are the best one to know. Now, so what happens actually in the first normal form? This normalization level ensures that each column in your data contains only atomic values, okay? So what do I mean by this? That a column cannot contain multiple values. So it has to have, okay, a single value for each row. We'll see how later. Now, with the second one, it eliminates what we call partial dependencies by ensuring that non-key attributes depend on the primary key. So what this means in essence is that there should be a direct relationship between each column and the primary key, and not between other columns. And then we have the third normal form, which builds upon the second normal form. So for any table to be in that normal form, it has to pass the second normal form. Now, in that normal form, it removes what you call transitive dependency by ensuring that non-key attributes depend only on the primary key. This level of normalization builds upon second normal form. So once you have the second normal form, it's easy to build upon, it's easy to build that normal form. We have the Boyce code normal form. This is a more strict version of 3NF that addresses additional anomalies, okay? We also have the fourth normal form, which is used to manage complex relationship. And finally, the fifth normal form is for managing what you call complex joins. Simple as that. So let's start with the first normal form. All right. Now, okay, for a table to be in the first normal form, it should follow the following rules. Number one, it should only have a single value attribute column. Okay, and then all columns in a table should have unique names, and the order in which the data is stored should not matter. So let's see how. If you could allow me to go back to our Excel draw. Okay, so I'll draw. Okay, I can draw here. So I'm gonna draw a new table here, a simple one, to show you this one is oh. There. I'll pick another one. And there. So I'll just create something simple like that. Here uh, I'll write ID, And then here I can write, maybe we are creating a book table. So here I'll write title. And then here I can write the author. And here I can write um, the person who borrowed, right? Now, we can record multiple values. So this first one, we can say ID number 1. Maybe the book is called, which book now? I'm thinking of a book, Outliers. The other is called, I've forgotten his name. Anyone who remembers the Outliers or Malcolm? Okay. Let's create a new one. Borrowed by, it can be borrowed. So we are trying to lend people books, maybe in a library database. So this book, Outliers, can be borrowed by multiple people. That's what I'm trying to do here. Now, can write names of multiple people here. Okay. Okay, I don't know why it's not creating. Let me add another row. All right. So I can write here Peter, Jason as well. Those are the individuals who have borrowed this book, right? Copy, paste. So the name was Outliers of Malcolm. That's the author. Now you can create another book. We can call this book. Let's write here too. Here we write, oops. Okay, this table there. Who moved my cheese? I'll just write the initials and then the other, I think, is Spencer. And then we can write the people who borrowed this book. We can write Mary and Jane. I'll just leave it like that, right? So let's open our SQL workbench and try to create a table that looks like this. So I'll head over to my SQL workbench. I'll open. If you're following along, if you're writing, you just write this table the way they are. All right, I'll log in. Okay, so I'll create a new database. Create database test. So once I execute that, I need to tell the server which database am I working with there. So you can execute, refresh here, and there it is. There it is. So there is this test. So let's create the table. Okay, so just create the table how you usually create the table. Okay, so write create table and then books. Open that, go to the next line, say ID. Okay, I'll paste the code once I'm done. Create a table ID. I'll say this is an integer, the primary key. It's an auto increment, comma. The title of this book, it's a variant char. I'll pass in there 100, and then the author, 50, and finally borrowed by. So I'll write names, var char 100. So we can close it at that. There, primary key. There. So this is our books table. So once I execute, this table will be created inside our test database. So let's execute if you're following along. To execute, you execute from here. So once I click, there it is. So we can see the log or the output is here. So let's refresh, and then we'll be able to see the table is here. Okay, so I can even retrieve the table. So currently the table is empty. So now we want to add a few sample data and see how the structure looks like. So I'll go to the next line, or I can comment this, okay, so that the server won't execute the statement again because I'm done. All right. So I'll just copy this because I've just remembered I did not share with you. And then Q&A, I'll just paste it to someone, Kelvin there. You can go and copy there. Yes, just copy the statement there. Great. Now, once you've executed, let's insert a few test data. So we said to insert data, you use insert command, insert into, like plain English. The name of the table is called books. So which are the columns that we want to insert data? Title. Okay. We also have author, and then borrowed by. Like that. Am I missing any? We have 1, 2, 3. Yeah, we are good to go. So the next thing is values. We specify the values that we want to store. Open that. I'll write here the book is outliers, comma. The other is called Malcolm Gladwell. So borrowed by, as we had said, Peter, John, I can actually add multiple people here. Audrey, like that. I'll create another row. I'll just copy this. To move my cheese. Mary, Brenda, Jessica, like that. I'll just close it at that. And then we execute. Okay, let's retrieve. We said you use select when you want to see how the data looks like in the table. Select all from books. Okay, so there it is, right? Now, there's a challenge, okay? If I wanted to, if I was to tell you to update this table the way it looks, it it's kind of difficult, okay, as you can see. So the way this table is, we have already violated what we call the first normal form. So a solution will be, we create a separate table for borrowers and then we link them to the books table, okay? So having our table looking like this, we have already violated the first normal form. Now, this is where I want to put you guys into a test, okay? Oh, let me share the code and then, so which one do I share now? All right, I've shared. Where have you got the test? Which test, Hilda? I'm aware, okay? The repo part, I wasn't able to create a repo, but I promised, as from next week, I'll be having a repo where you can just go and copy and then you test. Now, I don't know if these commands are, you're able to copy them in the charts. All right, so there it is. So we have our table looking like this. Now I want to test you guys. So now that I want to update my table, I want to delete this column. Which command will I use? Yes, you can type your answers in the chat. Oh, you can't copy. Okay, I can do this. I can save this file. Okay, I won't delete this command and then I can share them later. Yes, now I'm asking if I want to delete this column, which command will I use? Let me see the ones who have been paying attention in class now. Noah says drop. I can see Juanita says delete. Not really. Um, John, okay, John, yes, I'll share. Not delete, not drop. Yes, and Moniki says alter. Yes, it's an alter, but there's something else that is missing. Yes, alter what exactly? Not truncate, because when you say truncate, I'm removing all this data, and then this table will be empty when you use truncate. But for this case, I only want to delete this column. This is this column, the one that I'm hovering my mouse on, borrowed by this column. This is the one that I want to delete. Luyanda, believe I'm pronouncing also. Melanie says alter table drop column. Not really, Melanie. Yes, there's one who has said, okay, I'm gonna go with your commands. Is it Francis? All right. Alter table, books, drop column, borrowed by. Let's test it now. Okay, I'll open a new area so that I test it. Going by what you provided, use test, and then this is what Francis wrote. So I'll just write here, we want to delete a column, right? So alter table books. Why am I using alter? Because as I said, this table, the way it is designed, it's already violating what you call the first normal form. So we want to update it such a way that to achieve normalization in this table, okay? Now, of course, if I tell you to update this record, it's way hard, okay? Let's say, for example, you want to add another person here, maybe John, okay, not John, Mary. Maybe Mary has also borrowed the outlier. So you'll have to repeat the same. Peter, John, Audrey, then you add Mary. You see how hard it is, okay? It's time consuming. So instead of having to do this, why can't you just create another separate table and then link the two tables using a foreign key? That's the essence of having normalization. You get the point now? Yeah, you can react with a thumbs up if you've understood what I'm trying to say or what I'm trying to achieve. Great. So let's come back here and then, have I lost anyone? Yeah, okay. Yeah. Naima, I wish you could say where exactly have I lost you? Okay, again, Naima, were you able to create the table? Because I shared the commands in the charts. So we started by creating this table, a simple table, okay? I'm not using any complex table. And then we inserted a few dummy data, just 2 rows, not many rows. So we have outliers and then who moved my cheese. Those are the only books that we have in this table. If I try to retrieve them, okay, as you can see, this is how our table looks like. And we said that for a table to be in the first normal form, okay, a column should only have what we call an atomic value. By an atomic, that it means a row cannot store multiple data. So it means if we're to store, actually we should only have Peter here, and then we create another one for John, another one for Audrey, another one for Mary, another one for Brenda, another one for Jessica. So in essence, what we're supposed to have is 6 new rows, not just 2. You get the point now, Naima? Great. Now, what we're trying to do, so we are trying to delete this column so that we create a new table based on this column. And then that new table will be called borrowed, or we can give it any name, borrower's table. So I'll delete it. Okay, this code was provided by you guys. So I'll just go and execute it. There we have it. So let's try to retrieve and actually confirm it is true. The column has disappeared. So again, I'll write retrieve data from books table. So we use select all from books. There we have it, right? So we've deleted. Now it looks like we only have 1, 2, 3. So we are going to introduce a new table. I'll open a new working area. and then create a new table. So use test database, create table like that. So I'll say create table. We can give it a name, borrowers, like that. And then it will have borrower's ID, which is going to be an integer. Also a primary key as another constraint, which will auto increment because I want unique integers. The name of the person who borrowed, book ID, which is going to be an integer like that. We can close it at that. And then create a foreign key here. Foreign key, book ID, references, books on which column? This column. Close it. There. So I can now create this table, and down here, I can insert data. So insert into the name of the table's code, borrowers. Open that. Which column do we want to store data? Fname, comma, and the book ID. Specify the values. Open that and say, initially it was John. John borrowed book ID 1 because I knew it's the outliers. And the other one was Peter, also borrowed 1. The book with book ID 1 is the outliers. So that's the one that I'm trying to point to. And then we also have Audrey. Also borrowed 1. Let's create 2 more. Mary borrowed the second one, which is the who moved my cheese, and Jane, finally. Also 2. Like that. Now, if I execute, all this will be stored. So let's confirm it's going to be stored the way we expect it. So we click there, and then, okay, not yet. What's up with this one now? Oh, there. So let's retrieve and confirm actually the data was stored the way we expect. So we can select all from there we have it. Now there's the table. So do you see how this table looks like? So we have John, Peter, Audrey, Mary, Jane. And then we are referencing which book they have borrowed. Now with these 2 tables, we've broken down the first major table into two to achieve what we call the first normal form. Have you guys understood how the first normal form is usually achieved? Initially, good thing I did not delete, we had this. This was messy to even manage or update. But having two tables, it's easy to update and manage the two tables, and they look like this. Has this point landed? Thank you, Vivian, for that affirmation. All right. So can we now proceed to the second normal form? As I said, I'll not delete the code. I'll just see how I can provide you with all this code. Or alternatively, let me try something. Let me copy this, come to Exalidraw and give you guys access to the Exali. Let me see if I can be able to do something here. Okay. If I give you access, tell me if you're able to access. Export link, such a lesson. Okay, let me share the link there. So please join, and then please don't do anything messy. Just copy the way it is, and then you let me know which other one you want to copy. So yeah, you'll have the same information as me. So I can see you guys joining. I don't know if you've accessed the link. Have you guys managed to access? All right. So have you managed to copy the code? The code is here. You click and then Control A. Okay, no. A. Yeah. So Control A like that, then Control C. You come and now paste it. Open a new working area, and then you paste it with Control V. You'll have the same thing as me. All right. Now let's go to the second normal form. If you could allow me to switch to the slides. Now let's learn about the second normal form. Now, I don't know if you guys remember. Last week, we covered multiple types of relationship, right? So if you could kindly remind us, hey, you guys cannot access the code. Yes. If you could kindly remind us the types of relationship that we learned last week and see how by having those kind of relationship, we are able to achieve normalization. Okay. So yeah, can someone remind us the type of relationship that we mentioned last week? Nice one, Teresa. But Melo, thank you. Cynthia, thank you. Alphonse, amazing. Uh, Senelo. Senelo. Hey, Senelo, you share the name with one of my favorite artists, Sanele. I know you know Sanele. Yes. Now, Pauline, thank you. Melanie, amazing. All right, let's draw something very simple here. So I'll come here and draw a new one here. Or let me open Draw IO. Kindly just allow me to switch to Draw IO. And then I'll create another table here. Entity there. So I'll call this table courses. And then I'll just have a course name. We are trying to mimic the database in the campus or university. I'll delete that. And then we have another table. We call it student. Then we can have the student's name, their age, just the normal data you'll have to give to an institution before you are enrolled. Which other one now? Gender. All right, so we want to create what you call the many-to-many relationship. All right, so we said to create what you call a many-to-many relationship, we have to have what you call a bridging table there, meaning a student can enroll in for multiple courses, and a course can have multiple student, meaning many-to-many, right? So we'll say, we'll introduce a new student enrollment. I'm a class. And then this one will have a class ID. And then the student ID. I delete this other one. Create some space. Okay, I can just have it like that. Now I'll come and copy the cardinalities. And then this one there, this one here. I'll come and take another one. This one there, this other one there. So with this, we have what? The many-to-many, many-to-many there. So if you're drawing in your books, please just take the shortest time to sketch something quickly, and then you can try it once we end this class. Okay, this one does not have a link I can share so that you access. Does it? Or let me see. Share. Okay, yeah, as you can see, it's giving me something very complicated. So please just draw. Now we are trying to achieve what you call the many-to-many relationship. Now, if you could allow me to switch again, let's head over to Workbench. We already have our test data, so I'll remove this. Now we have to create how many tables? 3 good tables, right? Okay, did I say what 2NF mean? I just went and started designing the tables. Okay, apologies for that. Let me tell you what it means before we start. There it is. So for a table to be in second normal form, it should be in the first normal form. And it should not have what you call a partial dependency. Meaning, we should not have a column. Okay, I always need to exit there. So it means instead of having another column here that says maybe a student's name or one table doing everything, like student ID here, and then another one, student name. This now, when you have such kind of a column here, it means this depends on which one? On this primary key, right? So going by definition, for a table to be in second normal form, it should have, it should be in the first normal form, and it should not have what you call a partial dependency. Meaning, you see this student name, it also depends on the student ID. So this is what you call a partial dependency. When you go to the third normal form, you'll find that also this other one, the student ID, also depends on what? The primary key. Now, what we're creating here is what we call a transitive dependency. Instead of having all these in one table, we split the table into multiple tables, as we split the columns into multiple tables. Okay, the data for easy management. Now, I'll remove this because it will be quite difficult to manage when you have all the data in one table. So I'll go and create now. It's simple. Let's create. Right, create table courses. Open that. The ID or course ID. It's an integer. It's a primary key. It also auto increments. Comma. And then we say the course name. So maybe you can tell me your course name, the courses that you guys pursued in campus or in college. Variant and then I'll create the student table. Create table, student, um, student, student ID. I'll just come and copy this. Their name, another data we can store regarding a student, their age, which is an integer. Also the gender. Gender is a variant char. Now let's create the final table, course enrollment table or class. Create table class enrollment. Open that, go to the next line. And then say here, ID and then class ID. It's an integer and then the student ID. It's an integer. There we have our three tables. So we can execute this and then we insert the data. And then with just like that, we will have achieved what you call the second normal form. Yes, I know you're using, last week we were using the many-to-many, but but by now you understand that whatever you've been doing, you are already applying normalization. It's only that you did not know that what you're doing is normalization. But essentially, when you're creating this table, you're applying normalization. It's only that you're not able to pinpoint at that time like this is normalization. Now I'm just showing you what you are doing actually. You are adding or you're applying normalization. So yeah, going forward, I know you'll be paying attention now. You see how everything that you learned, like in previous class, always builds up in the next class. So whatever we've learned today, when it comes to next week, you'll see that the topic for next week will be building upon what we covered today. Yeah. So once I execute this, these three tables will be created. So, okay, let me insert the data here. Okay, it will be too messy. Not even readable. I want to insert everything at once. Insert into courses. Course name. It's just course. Yeah. Values. Let me see what you guys suggested. You went to school to learn entrepreneurship, computer learning, information science, math and comp science, computer technology, information system. All right. I'll create another one, just two, because of time. Information system, biology. I'll insert into student. The name of the table is called student. Open a bracket, specify the columns that you want them inserted with data. So we have name, age, and gender. Age, gender, like that. Values, you can have John or Joseph. Joseph age is 20, gender is male. Joseph, the father of Jesus. I don't know if he's aware his son is going to be crucified tonight. Oh, tomorrow, not today. His son is going to be crucified tomorrow. Right now, his son is washing the disciples' feet. All right, I'll create another one. Magdalene. Yeah, we have a Magdalene in this class. People say Magdalene was Jesus' girlfriend. I heard it from our bishop. 22. She's a female. Hey, my bishop, wherever he is right now, I know he's wheezing. Okay, let's insert new data in there. Course enrollment. Now, insert into, it's class enrollment. There. So open that and say class ID. Those are the only things I need. Class ID, class ID, like that. And student ID. Values. I'll just play here with numbers. So when I write like 1, it means, you see, when you come to the class, so this is the first one, this is the ID 1, and then this ID 2. So it means information is here. So you can just replace this with information system, and then maybe the student will be Magdalene, like that. Another one we can have is 2, 1, like that, going on. So I'll just leave it like that. We can now execute. Okay, I hope there's no error. So we can execute. All right, and then retrieve all the data. So I'll just refresh here, and then you can see we have the course, the courses. There it is. We can have the student. There it is, Joseph Mary Magdalene, and the class enrollment there. Now, with that, we've achieved what you call second normal form. Anyone who's lost? Yeah, we just use the many to many. Yeah, so finally we have the third normal form. So with the third normal form, I'll use a very simple example and then we close it. So that we can go to church. I also want to go to church. Been long since I was there. Um, Let me see. I'm thinking of an example to use. One that is very, very simple. Then we call it a night. Okay. All right. Um, okay, let's come to Exalidro. I'll create a new table here. Okay, let's say here. Remember I said what? That normal form builds upon 2NF. So if you already have 2NF, there's no point of having it will be easy for you to have a that normal form. Here we can write A, ID, name, subject ID, subject. I'll add a new column. Gender. Okay. All right. So we have a new table. We have this number of columns. So we have ID, name, subject ID, subject, gender. Okay. So imagine a scenario where you have a table that looks like this, and then this table has data already, right? Now, as I said earlier, you'll find a column like this one. We have the subject, right? Maybe a subject here is physics. Okay. Okay, this one is becoming even hard. Let me go back to this one that I'm used to. Okay, no more Jesus jokes. Uh, I'll create a new table. I'll just call it students. And then we can have the ID, the name, subject ID. We can also have the subject name. We can also have the agenda and so on. Now we have this column and this column. These two columns can be broken down into another table. The reason being, you see, this column depends on the subject ID, okay? And then this subject ID depends also on which other key, this primary key, transitive dependency. Non-key attribute depends on, a non-key attribute depends on another non-key attribute, which depends on a key attribute, transitive dependency. Now, if we're to split, we will have to split these two. We create a separate table, and just like that, we would have achieved that normal form. Because I said to achieve that normal form, you have to have what you call the second normal form, as simple like that. All right, going by the definition of the book, of the slides. So that normal form table is said to be in that normal form when it satisfies the first normal form and the second normal form, as simple like that. And it does not have transitive dependency. As I said again, you see these two, this one depends on this one, and this one depends on this one, creating what we call a transitive dependency. So we are trying to remove what we call a transitive dependency. Such these tables, we have two tables which are related to with each other to improve query performance. And with that, we would have achieved that normal form, as simple like that. So if I come back to Workbench, do I now create another table? Okay, use test, because you already have the student table. So I'll just give it a different name, students with an extra S. So create table, students, open that. I want to save on time before the pastor start preaching. Oh, Bishop, what is Bishop? So I'll just come and copy that, have it here. And then we said which other thing are supposed to be here. The name and the gender. So we are splitting this table to be two, like that. So name, a variant char, like that, and then we create the other table. Subjects, subject, ID, and then subject name. We can have this as what? Variant char. Then we can create relationship. Foreign key, foreign key, forgot to add another column, or you can just, if you decide to leave it the way it is, it's still okay. But I now want to make sure we have a relationship between them. So I'll just pass in a student ID. Like that. So I'll just say here stud ID references like that. There. So you can insert data with this. So we would have achieved the third normal form, just like that. Simple. Yeah. And with this one, you can see the kind of relationship is the one to many. Yeah. So just like that, I'm done with the first, the second, and the third. Unless you have any question, I think that's where I end it with the first, the second, the third. Yeah, I think I did not take so much time explaining that. Now, can I get someone to read for us the checkpoints question as we prepare ourselves with hammers and canes to go and whip Jesus? All right. So, oh, you want the slides? Okay, let me share the slides. Jesus right now is kissing Judas. Oh, Judas is kissing Vicky Blessings. Yes, Vicky. Please read for us.
Okay, the first one is, why do we need normalization in DBMS?
All right, my smart people, why do we need normalization? Remember, I started by explaining why we need normalization. The importance of normalization is still here. So you can tell me, just type in the charts. I'll be mentioning you, Ruth, the code as well. Yeah, the code. Yes. I'll paste the code for sure. To reduce redundancy, Karen, thank you. Rose, nice one. Noah, perfect. Yeah, I can see you guys. You've grasped the concept around normalization. Read for us the second one. Blessings. As
Okay.
we ask for blessings upon us. Yeah,
Okay,
just read the
so
second one.
the second question, what are the different normal forms in DBMS?
Yeah, so what are the different types of the normal forms that we have in DBMS? All right. The first A, B, nice one. Melanie, impressive. Let A, B, C, and F. Zoe, Hilda, Paul, Arnold, amazing. Now the final one.
Okay, number 3, what are non-key attributes in a table?
Yes. Now, what are non-key attributes in a table? What are non-key attributes in a table? Hey, you guys have taken time to answer this one. Looks like number 3 was a tough one. Juanita, an attribute that is not a primary key. Nice one. Fields that are not part of primary key. Lawrence, keys that are not primary key. All right. Okay. Vicky Blessings, do we have your blessings to proceed with the next slide?
Yes, we do.
All right. Amen to that. So I don't know. Can we still have Vicky? Vicky, do you mind reading for us this one? These other ones, or I can pick
I
another
don't
one.
mind. I don't mind.
All right, cool. All right, do this. Read the first 3, and then I'll pick another person to read for us the remaining 2, and then we close it.
All right, no problem. So the first one, by identifying entities and relationships early, you can structure your database to avoid redundant and inconsistent data. Should I continue?
Yes, please.
Okay. Applying normalization techniques, the first, second, and third NF, helps eliminate data redundancy and ensures data is logically and efficiently stored, reducing anomalies. And then number 3, in first NF, we eliminate repeating groups, and ensure that each column contains only atomic values.
Impressive. Thank you so much. I think we've been
Thanks, man.
blessed. Amen to that. Hey. Now let's pick another one. Jonathan. Jonathan Muresi. Yes, Jonathan. Was it Jonathan who destroyed the building?
Hello.
Yeah, Jonathan. Yes,
Hi, how are you?
I'm good. How are you?
I'm good as well. I hear you want to roast me with Bible terms.
No, I think it was Samson. Hey, please read for us the remaining two.
All right. 2NF builds upon 1NF by ensuring that non-key attributes are fully dependent on the entire primary key. In NF3, we ensure that non-key attributes are only dependent on the primary key, eliminating transitive dependencies.
All right, we're done.
Yes.
Thank you so
Finished.
much, Mr. Jonathan. So what did Jonathan do in the Bible?
Thank
So that
you as
I
well.
see where to get. No, I'm asking, what was Jonathan's role in the Bible? Did Jonathan have a
First of
role
all,
in the Bible?
Yes, he did. First of all, people confuse Jonathan and Jonah. Jonah, the guy who was swallowed by the fish, and Jonathan, the best friend of David.
Oh,
Yeah.
David is the one who killed Goliath.
Yes.
Impressive. Okay, yes. Can see I haven't forgotten my Bible. Hey, my Sunday school teacher is happy. Okay, so as we about to conclude, I want to play you this song. This is the closest I could get to gospel. I'm sorry, guys. I know I've been seeing your request, play gospel, play gospel. I couldn't get any other gospel apart from this. No, this is the best gospel. All right, for those watching the recording, this is where I end the class, and then see you next week. Thank you so much. Yeah, now I think I'll take in questions, a few ones, and then we can end our session. So I'll stop recording.